Yes. Hello friends, welcome to the session. Continuation of chapter 5, that is power measurement. I given some introduction to the three-phase power measurement and I explained what is 3 wattmeter method of measurement, then how to go for the 2 wattmeter method according to Blundel's theory, then how to select the number of wattmeters. This I given. Okay. Now in this session we will continue with the 2 wattmeter method of power measurement. This one important concept for any competitive point of view. That's why I given 5-star also. Okay, this is one of the 5-star concept. In every competitive exam, compulsory you can expect the questions from the 2 wattmeter method. Okay. First we will see how to measure the power using 2 wattmeter method. I am explaining the concept for lagging power factor loads. For leading power factor loads, by changing the sign, we can get the same formulas only. Okay, just by changing in the same formulas, whatever the formulas we can get in 2 wattmeter method. For lagging power factor loads, just by changing positive, negative, then we can get the formulas for leading power factor loads. No need to explain that one. Okay, you remember mainly for lagging power factor loads, then exactly opposite for leading power factor loads. Okay, then let us consider a 2 wattmeter method of power measurement. Okay, first all of you parallelly draw this one. Here I am explaining for star connected load. For delta connected load also same formulas. Then how it is delta connected, that I will give by giving the circuit also. I will explain. Okay. First we concentrate on star connected load. Okay. Now let us consider a star connected load. Let us consider for, I am explaining for lagging power factor loads. Let it is a balanced load. That's why equal load impedance I am taking. Yes. Here 2 wattmeter method. I am connecting wattmeter here in R line. This is R. I taken RYB phase sequence in clockwise. This Y. This is B. RYB phase sequence. This is W1 wattmeter and this is W2 wattmeter. Yes, the pressure call inductance is LP, the pressure call resistance is RP. This also pressure call inductance LP, pressure call resistance RP. Here I am explaining for lagging power factor loads. Yes. Lagging power factor loads. Yes. Here the phase sequence is RYB phase sequence. The wattmeter readings is also depends on the phase sequence. Okay, here I am explaining RYB phase sequence. If the phase sequence changes, how to write the readings of wattmeters directly, that also I will explain. But up to now you concentrate with this assumption I am explaining this W1 is connected between R and B, W2 is connected between Y and B. The wattmeter readings depends on the phase sequence. It also depends on the connection of the wattmeters. Understood? But whatever the wattmeter readings I am deriving here, with the assumption of RYB phase sequence, and W1 is connected between R and B, and W2 is connected between Y and B. If it is not mentioned that what is the phase sequence, where the wattmeters are connected, if it is not mentioned like that, then directly go for these formulas directly. If phase sequence is given and connection of wattmeters are given, where the wattmeters are connected, if it is statements are given, then according to that you write the formula. Don't apply directly. Clear? Okay. Now how to write directly also, that I will give. Then lagging power factor loads with the assumption of RYB phase sequence. RYB phase sequence. Okay. Always you know that in three phase the phase sequence is taken in clockwise. Okay. Let this is VR, this is VY, and this one is VB. Yes, I told already, a 2 wattmeter method is applicable if the neutral point or common point is not available. Yes. This is VRY. I am writing these voltages according to phase sequence. VRY, and this one is VYB, and this one is VBR. Okay, and this current is IR, and this current is IB, and this current is IY. Okay, now these are the 2 wattmeters. This is W1 and W2 wattmeter. Now we want to prove that the sum of the 2 wattmeter readings indicates sum of the 2 wattmeter indicates 3-phase power. That I already given that in the case of resistive loads, but here I am explaining with respect to inductive loads. I am taking the lagging power factor loads. Okay, now tell me, wherever we are calculating the wattmeter reading, it may be single phase or 3-phase, wherever we are calculating the wattmeter reading, I told that fundamental concept, wattmeter reading equal to pressure coil reading into current coil reading into power factor. That is a fundamental concept. Now before that, what is VR, VY, VB is which voltages? Phase voltages I taken. These are the phase voltages. Then what about VRY, VYB, VBR? These voltages according to phase sequence. These are the line voltages. Okay, but this is a star connected now. In a star connected, line voltage equal to √3 times of phase voltage. But what about IR, IY, IB is which currents? Phase currents is equal to line currents because of which connection? Star connection. Okay. Now tell me, what is the W1 reading? You tell what is the W1 reading. W1 is pressure coil reading. What the pressure coil measures? VRB. This pressure coil measures VRB. But you have the doubt here. Sir, why you taken VRB? You take VBR. That is meaningless. The reason is, you measure the pressure coil reading. You take the pressure coil voltage where the current is entering. The current is entering at this now. Current is entering from R. That's why you take VRB. This measures VRB. Pressure coil measures VRB. That is VRB into current coil reading. What this current coil measures? IR. Yes. VRB into IR. Now cos of angle between power factor na. Power factor means angle between voltage and current. VRB and IR. This is W1 reading. Now similarly, what is the W2 reading? You tell me. What is the W2 reading? Yes. W2 is, yeah, this W2 reading. Where the current is entering? Current is entering from Y. That's why you define from Y itself. Then what is the pressure call reading? VYB. VYB. What is the current call measures? IY into cos of angle between VYB and IY. Okay. Now we know that VRB is line voltage, IR and IY is line current, that is equal to phase current. But I want to find the angle between VRB and IR. What is the angle between VYB and IY? To find the angle between VRB and IR and VYB and IY, then you go for the phasor diagrams. Yes, go for the vector diagrams. Then first you draw the vector diagrams to find this what is the angle between VRB and IR and VYB and IY. Yes, we know that in a three-phase system, all the phase voltages are displaced by 120 degrees. And this is VR. All the phase voltages are displaced by 120 degrees. Yes. This is Vy. And this one is Vb. Always the phase sequence is clockwise, the vector rotation is in anti-clockwise, that you know. That's why the vector rotation is anti-clockwise direction. This is vector rotation. Rotation in anti-clockwise direction. If the vector rotation in anti-clockwise direction means test R, Y, B. First R, next Y, next B. Then R, Y, B phase sequence. Sorry. R, Y, B, the vector rotation is anti-clockwise direction. Vector rotation. Then if you take phase sequence in clockwise means R, Y, B. Like this, clockwise direction. Understood. Now, tell. Here we are taken lagging power factor loads. And this is VR. Okay. And this is Vy. Then this is how much? 120 degrees. This is how much? 120 degrees. This is how much? 120 degrees. This is displaced by 120 degrees. Sorry. Take this is 120. This also 120. This is all the phase voltages are displaced by 120 degrees. Assuming that lagging current, lagging loads, then I taken this is phase sequence in clockwise R, Y, B, but vector rotation is in anti-clockwise direction. Okay. Then first R, then current lags the voltage. Let this IR. IR lags VR by angle of pi. I told already, vector rotation is in anti-clockwise. First voltage, next current. First voltage, next current. That's why current lags the voltage by angle of pi. Then this is IB. Current lags the voltage by angle of pi. Okay. And this is IY. Current lags the voltage by angle of pi. Clear? Now, you want angle between VRB and IR. IR you know, but you want VRB. As for vector notation, what is VRB? VR minus VB. Then VR you know, but you want minus VB. How you can get minus VB, you tell me? This is plus VB, exactly opposite you project. Then you can get minus VB. This exactly opposite. This we can get minus VB. Yes? This minus VB. But you want VRB, no? Then This exactly opposite means this is how many degrees? 60 degrees. And this also 60 degrees. Then according to parallelogram law, the resultant is in between these two. Then you can form one parallelogram. This is VRB. Yes, but you know that we want angle between VRB and IR. This is how many degrees? 30 degrees. This also 30 degrees. But you want angle between VRB and IR. This angle you want. Tell me what is that angle. The angle between VRB and IR is this one. This is 30. This is pi. Then what this angle? 30 minus pi. Therefore, the angle between VRB and IR is 30 minus pi. It's over. Now similarly, you want to find angle between VYB and IY. Then how to find the angle between VYB and IY? As per vector notation, how to write VYB? VY minus VB. This VY, this is minus VB. Then according to parallelogram law, the resultant is in between these two. According to parallelogram law, then you can form one parallelogram. Yes, what this one? VYB, VY minus VB. Now, how much this angle? This angle is 30. How much this angle? This angle also 30 degree. But you want this angle. Then what is the angle between VYB and IY? 30 plus pi. Therefore, the angle between VYB and IY is 30 plus pi. This I am drawing this vector diagram with the assumption of lagging power factor loads. That's why I taken current lags the voltage. Current lags the voltage. As per vector rotation is an anti-clockwise. First voltage, next current. First voltage, next current. That's why lagging. If the same vector diagram, if you want to draw for leading power factor loads, then IR leads VR, IY leads VY. If IR leads VR means this becomes 30 plus pi. IY leads VY means it becomes 30 minus pi. You try that one. Exactly opposite you can get now. Then if you take IR leads VR, same. You take IY leads VY. Now you measure this angle. You can get this one is 30 minus pi. Then you can get this is 30 plus pi. Then exactly opposite. That's why no need to draw the vector diagram again for leading power factor. Just to mainly concentrate on lagging, then exactly opposite for leading. Understood? Now, tell me. Now what is the W1 reading? Now what is the W1 reading? Therefore W1 equal to this VRB is line voltage, VL, IR is line current, that is equal to phase current, that is VL into IL. What is the angle between VRB and IR? 30 minus pi. Let this is 1. Now what is the W2 reading, you tell me? Yes, W2 equal to VL into IL cos, what is the angle between VYB and IY? 30 plus pi. 30 plus pi. Let this is equation 2. This is for lagging power factor loads. Lagging power factor loads. If it is asked for leading power factor loads, then what is the W1 equal to? VL, IL, you try that vector diagram by taking the leading currents. Cos 30 plus pi, then W2 equal to VL, IL, cos 30 minus pi. This is for leading power factor loads. But mainly I am concentrating only lagging. Remembering the formulas for leading is exactly opposite. That's why no need to concentrate this. This you remember, mind. Exactly opposite you remember for lag. Then W1 equal to VLIL cos 30 minus pi. W2 equal to VLIL cos 30 plus pi. Yes. But every time we don't expect the wattmeter connection like this only. We may connect this wattmeter between R and Y and B and Y. We may connect the wattmeters between and B and Y and R. You may connect the wattmeters between Y and R and B and R. Any one line is taken as a reference now. But here I taken line B is reference. With that assumption, I am giving this wattmeter reading and assuming that lagging power factor loads. But if the wattmeter connections are changes, if the phase frequency changes, how the wattmeter readings will be changes, that you concentrate. Every time no need to draw the vector diagrams, all these. Directly also we can answer. Yes, one observation here. So listen please. Let this is R and this is Y and this is B. RYB phase sequence. We connected like this. Okay. Yes. You write this as a note. This is R and this is Y and this is B. Take that RYB phase sequence. RYB phase sequence. Okay. Now W1 is connected between R and B. W2 is connected between Y and B. If it is connected like this, what the W1 we are getting? VLIL cos 30 minus pi. What the W2 we are getting? Yes, VLIL cos 30 plus pi. These are the readings we are getting now. Yes. Then 1 minute please. W1 is connected between R and B. W1 is connected between R and B. This is VRB. W2 is connected between Y and B. This is VYB. According to RYB phase sequence, after R, what you want to get? Y. But here VRB. That means it is not following the phase sequence. After R, we want to get Y phase. But here we are getting RB. Not following the phase sequence. That's why we are getting 30 minus pi. See, here I am giving one observation to write the wattmeter readings directly. Understood? Now, W2 is connected between Y and B. According to phase sequence, after Y, what you are getting? B. VYB. Phase sequence is following. That means, for lagging power factor loads, this statement important. For the lagging power factor loads, if the phase sequence is not followed, then you get 30 minus pi. This concept is applicable for either 2 wattmeter method or 3 wattmeter method. It is applicable. Okay. Understood. If the phase sequence is not followed, you take 30 minus pi. If the phase sequence is followed, then you take 30 plus pi. Understood. For example, for same phase sequence, if the wattmeter reading is connected like this, all this I am explaining for lagging loads only. All this I am explaining for lagging loads. R, Y, B. Take RYB phase sequence. RYB phase sequence. According to RY phase sequence, I am explaining. Okay. This is RYB phase sequence concept. And assuming that lagging loads. Now, for example, W1 is connected between R and Y. And W2 is connected between B and Y. Take any one line is reference. Don't take at a time 2 lines are reference. Okay, that's why W1 is connected between R and Y. W2 is connected between B and Y. Don't take Y and B. This is not the reference. We have taken Y is the reference. Only one reference at a time. Now, what is W1 reading? W1 is connected between. Yes, I want W1 reading now. What is W1 equal to? VL, IL, cos. You can get 30 plus pi or 30 minus pi, that you will see. This concept is lagging power factor loads. W1 is connected between R and Y, na? VRY. After R, what we are getting? Y. Phase sequence is followed. RYB phase sequence. Phase sequence is followed. Then you get a 30 plus pi. Now W2. W2 reading you tell me. W2 equal to VLIL cos. You get 30 plus pi or 30 minus pi. Then connected between B and Y. This is connected between VBY. After B, according to phase sequence, after B, again what you want to get? R. But here, after B, what it is given? VBY. Phase sequence is not followed. Then you take 30 minus pi. Like that, wattmeter readings will be changes. Based on the connection, the wattmeter readings will be changes. That's very important. Okay, this is for lagging power. For example, if it is given like this. Okay, first you note down this quick. This you note down as a note. This is note 1. As it is this one. This is note 2. RYB phase sequence and lagging power factor loads. Lagging power factor loads. Yes, quick note down. Yes. Over? Yes. See, for example, same lagging power factor loads. RBY phase sequence is given. RBY phase sequence. Phase sequence. See, for lagging power factor. This also for lagging power factor loads. This is R, this is B, this is Y. RBY phase sequence. Let W1 is connected between, here no problem, you take RYB. But according to phase sequence, you write the wattmeter readings. Okay. W1 is connected between R and Y. Then W2 is connected between B and Y. Understood. Let us assume that W1 is connected between R and Y. W2 is connected between B and Y. Then what the W1 reading you tell me? W1 is VLIL. Is it cos 30 plus pi or cos 30 minus pi? That you will see. What the W1 connected between R and Y? R and Y means VRY. But as for phase sequence, RBY you want. After R what you can get? B. But after R what you are getting? Y. But phase sequence is not following. Lagging power factor loads, phase sequence is not followed. Then what you can get? 30 minus pi you can get. Understood. Now what is the W2 reading? W2 equal to VLIL cos is 30 plus pi or 30 minus pi, that you will see. Then where the W2 is connected, always you take the one is reference line only. Always Y here. That's why B and Y. Connected between B and Y. After B, according to phase sequence, after B what you are getting? Y. After B, Y. Then phase sequence is followed. Then you take 30 plus pi. Okay, like this you can write the any wattmeter reading. That means the wattmeter reading, see, W1 is connected between R and Y. W2 is connected between B and Y. Here also, W1 is connected between R and Y. W2 is connected between B and Y. The connection is same. But here W1 equals 30 plus pi we are getting. But here 30 minus pi we are getting. Why? Yes, based on the phase sequence. That means the wattmeter readings not only depends on the connection, it also depends on the phase sequence. This is for RYB phase sequence. This is RBY phase sequence. Understood or not? For example, you take for leading power factor loads. I take an RYB phase sequence for leading power factor loads. Leading power factor loads. One more observation here. The phase sequence is same. See, important observation. Here phase sequence is same. But here W1 30 minus pi, but here 30 plus pi. Why? The connection changes. The connection of wattmeters is changing. That's why here also connection is same, but wattmeter readings are different. Why? Phase sequence changes. That means the wattmeter reading depends on the connection of wattmeter, phase sequence. It depends on the phase sequence also. For example, you take the R by B phase sequence, leading power factor loads. Leading power factor loads. Yes, this is R, this is Y, B. W1 is connected between R and B. W2 is connected between Y and B. Like this. W1 is connected between R and B. W2 is connected between Y and B. Now, what the W1 we are getting, this already I given. This is for leading power. W1, VLIL cos 30 plus pi. VLIL cos 30 plus pi. What the W2 you tell me? VLIL cos 30 minus pi. Yes. Observation you see. From this observation, then you write the wattmeter. Exactly opposite. For leading power factor loads, if the phase sequence where the W1 is connected between R and Y, after R we are getting Y, phase sequence is followed. For leading power factor loads, if the phase sequence is followed, then you take 30 plus pi. Sorry. Phase sequence is VL, R, sorry, this is connected between R and B. W1 is connected between R and B. After R, according to phase sequence, we want to get Y, but here we are getting B. Is it phase sequence is followed? No. That's why, if the phase sequence is not followed, here you take 30 plus pi. If the phase sequence is followed, then you can. What the W2 is connected between B and Y. W2 is connected between Y and B. This is connected between Y and B. This is connected between Y and B. And this is connected between R and B. Then what the W2 is connected VYB. After Y we are getting B. That means phase sequence is followed. Then you get 30. Exactly opposite. In lagging power factor loads, if the phase sequence is followed, then you take plus. If the phase sequence is not followed, then you take 30 minus pi. But for leading power factor load, if the phase sequence is followed, then you get 30 plus. Sorry, if the phase sequence is not followed, then you can get 30 plus pi. If the phase sequence is followed, then you can get 30 minus pi. Understood? Exactly opposite. One more observation here. Phase sequence is same. The connection of wattmeter readings is also same. W1 is connected between R and B. W2 is connected between Y and B. Here also, W1 is connected between R and B. W2 is also connected between Y and B. Connection is same. Phase sequence is also same. But the wattmeter readings are different. Here 30 minus pi you are getting 30 plus pi. Why? Because of power factor. That's why wattmeter readings depends on the connection of wattmeters. It depends on the phase sequence. It also depends on the load power factor. This is very important. In all the cases, don't take like this. W1 is 30 minus pi, W2 equal 30 plus pi. Like that you don't take. But if it is not mentioned where the wattmeters are connected, then what is the phase sequence and what is the power factor, like that it is not mentioned, then directly you take this case only. W1 equal cos 30 minus pi, W2 equal cos 30 plus pi. If the phase sequence is given, if the power factor is given, connection of wattmeters also given, according to that you can write the formula. Understood or not? Okay. That means finally mainly two statements mainly you concentrate. For lagging power factor loads, if the phase sequence is followed, then you take cos 30 plus pi. If the phase sequence is not followed, you take cos 30 minus pi. For leading power factor loads, if the phase sequence is followed, you take 30 minus pi. If the phase sequence is not followed, then you take 30 plus pi. Exactly opposite. Therefore, wattmeter readings depends on. Finally, I am giving the statement. You write as a note. wattmeter readings depends on wattmeter readings in a three-phase sampling depends on one is phase sequence, connection of wattmeters, and load power factor. Where it is connected, what is the phase sequence, what is the load power factor. In all these three cases, it depends. The readings of wattmeters depends. Okay, but mainly I am discussing this concept only. With respect to this only I am explaining in detail. But remaining that you concentrate based on the connection how to write, based on the phase sequence how to write. This knowledge you remember. You try for leading power factor loads. W1 is connected between R and Y. W2 is connected between B and Y. Then you try. Then exactly you can get this is 30 minus pi, this is 30 plus pi you can get. That you try. Understood? Okay. Quick note down. But don't confuse. Here W1 is connected between R and Y. W2 is connected between Y and B. Change the arrow marks. This like this. Here W1 is connected between R and Y. W2 is connected between B and Y. Okay. Here W1 is connected between R and Y. W2 is connected between W1 is connected between R and Y. W2 is connected between B and Y. But the phase sequence is RVY. This is R and Y. This is B and Y. Clear? Then RY is facing leading forward. This is R and B, Y and B. Yes? Note down, quick. Like this you write the wattmeter readings directly without drawing the vector diagram. But this concept is applicable for a three-phase wattmeters or 3 wattmeter method, 2 wattmeter method. If any single wattmeter also given, in that case also it is applicable. But in special connection it is not applicable. Okay, that you concentrate. Finally, you can apply this method for 3 wattmeter method and 2 wattmeter method to write the wattmeter readings directly. Clear? Okay. Now, I want to extend this concept mainly for lagging power factor loads. Then this concept I want to explain. Now see, using 2 wattmeter method, what the sum of the 2 wattmeter readings will indicate, all this I want to explain. Okay. Now we calculate W1 plus W2. Do this calculation. W1 plus W2 you can do. Then what is VLIL is common? Cos 30 minus pi plus cos 30 plus pi. Okay. Now W1 plus W2 equal to VLIL into cos A minus B plus cos A plus B. 2 cos A cos B. It's 2 cos 30 cos pi. Then what you get? W1 plus W2 equal to VLIL into 2 into cos 30 root 3 by 2 cos pi. Then 2 cancel. Then what is the W1 plus W2? That is root 3 VLIL cos pi. Here we are assuming that star connected load. Shall we write like this? Root 3 into VL is root 3 times of V phase, IL is I phase. This is equal to into cos pi. Therefore, W1 plus W2 equal to root 3 VLIL cos pi is equal to 3 into V phase, I phase cos pi. This is 3 phase active power. I told already this formula. That's why in a 2 wattmeter method of power measurement, some of the 2 wattmeter readings indicates 3 phase active power. This one important statement you remember. Therefore, first one is in 2 wattmeter method, some of the 2 wattmeter readings indicates three phase active power. Okay, then W1 plus W2 equal to root 3 S VLIL cos pi. This is equal to 3 into V phase I phase cos pi. Some of the 2 wattmeter readings indicate the 3 phase active power. One more point to remember, 2 wattmeter method not only for active power measurement, it is also used for reactive power measurement. Then you can calculate reactive power measurement. Yes, 3 phase reactive power measurement. 3 phase reactive power measurement using 2 wattmeter method. Then how to measure the 3 phase reactive power means? For that you do this one, W1 minus W2 equal to VLIL cos 30 minus pi minus cos 30 plus pi. Okay, then cos A minus B minus cos A plus B. Then what is the W1 minus W2 equal to VLIL 2 sin A sin B, 2 sin 30 sin pi. Then what is the W1 minus W2 equal to 2, that is VL IL sin pi. But it is not a 3 phase reactive power. But how we can get the 3 phase reactive power? Then 3 phase reactive power equal to then root 3 VLIL sin pi. Therefore, by knowing the 2 wattmeter readings, 2 wattmeter readings, how to calculate 3 phase reactive power? Root 3 into W1 minus W2. Subtract 2 wattmeter readings, multiply with root 3, then that gives the 3 phase reactive power. Yes, this is the measurement of 3 phase reactive power using 2 wattmeter method. Okay, this is 3 phase active power measurement. Some of the 2 wattmeter readings indicate the 3 phase active power. In order to get the 3 phase reactive power, you subtract the 2 wattmeter readings and multiply with root 3, that gives the 3 phase reactive power. Yes, quick note down. Over S. Then by using 2 wattmeter method, not only the apparent, not only the reactive power, not only the active power, you also calculate apparent power. Yes. Third one is a 3-phase apparent power. How to get the 3-phase apparent power? Yes. We know that this is active power and this is reactive power and this power is apparent power. Let this is pi. Yes, sir. Now, how to get the apparent power is, let apparent power is S. Then what is S equal to? Square root of P square plus Q square. What is P? What is Q? That you know. P equal to W1 plus W2. What is Q? Root 3 into W1 minus W2. Yes. Then you also calculate power factor and power factor angle. Power factor and power factor angle, or power factor angle and power factor. Power factor, angle and power factor. We also measure power factor, angle and power factor. Now, can you tell me what is cos pi equal to? Cos pi equal to P by S. This is one formula you can use. P by S. Okay. This is cos pi equal to P by S. Active power by apparent power. Or otherwise, what is tan pi equal to? Tan pi equal to S. What is tan pi equal to? What you can get? Q by P. Q by P. That is root 3 into W1 minus W2 by W1 plus W2. Then what is pi equal to? Tan inverse root 3 into W1 minus W2 by W1 plus W2. To solve mainly any problems in a 2 wattmeter method, this formula is important. Or I will write this formula instead of here. Is completed? Yes. Tan pi equal to Q by P. Then from this, what is pi equal to? Tan inverse root 3 into W1 minus W2 by W1 plus W2. This is the calculation of power factor angle. Very, very important 5-star formula. This also important. To solve most of the problems in 2 wattmeter method, mainly concentrate this formula. Tan pi equal root 3 into W1 minus W2 by W1 plus W2. All these formulas I am giving for lagging power factor loads. If it is given that leading power factor loads, just you change this one. This W1 minus W2, instead of W1 minus W2, you take W2 minus W1. That is the only difference. But here there is no change. It may be lagging power factor load or leading power factor load. Some of the 2 wattmeter readings indicate the 3-phase active power. But difference of 2 wattmeter readings into root 3, that gives the 3-phase reactive power. But if it is a lagging loads, root 3 into W1 minus W2. If it is a leading loads, root 3 into W2 minus W1. That is the only difference. Remaining all the formulas are same, either lagging or leading. Clear? Okay. Like this we can measure the power factor angle and power factor. Once you know the power factor angle, then you take the power factor equal to cos pi. You take the power factor equal to cos pi. Or otherwise, if you know only tan pi, you don't know about angle, directly from tan pi you want to calculate the power factor, then you can apply this formula also. How to calculate directly from tan pi? You know the cos pi equal to 1 by secant pi. Then cos pi equal to 1 by secant pi in terms of tan pi. square root of 1 plus tan square pi. Using like this also you can calculate the power factor. Secant pi, I am writing the formula in terms of tan. 1 by square root of 1 plus tan square pi. Understood? That means by using the 2 wattmeter method, we can measure 3-phase active power, we can measure 3-phase reactive power, then we can measure 3-phase apparent power, we can measure the power factor angle and power factor. We can measure the power factor angle and power factor. Understand? Quick note down. Yes. One more final observation you remember here. Yes. Fifth one. A 2 wattmeter method of power measurement. A 2 wattmeter method of or a 2 wattmeter method is applicable. Yes, without neutral only. Without neutral only. I told already. With neutral, this is not applicable. Next, sixth observation. A 2 wattmeter method of power measurement. It may be active or reactive power. A 2 wattmeter method of power measurement. Method of power measurement is applicable for yes, load, or you take source, load, source balance, load balance, source balance, load unbalance, source unbalance, load balance, source unbalance, load unbalance. In all the cases it is applicable. I am talking about a 2 wattmeter method of power measurement. Power means it may be active power or reactive power or apparent power. Then in all the cases it may be source balance or load balance, both are unbalanced, one is balanced, one is unbalanced. In all the cases it is applicable. Seventh observation. A 2 wattmeter method of power factor measurement. Power factor measurement. I am talking about power factor measurement. Is applicable only for source load, source balance, load balance. Then only it is applicable. But in under unbalanced condition, measurement of power factor using 2 wattmeter method is not applicable. Load unbalance means each phase load impedances are not equal. Then we can say that is load is unbalanced. Source unbalance means then whatever the voltages are there, VRY, VYB or VBC, VRY, VYB or VBR, that voltages are not balanced. This is not exactly 120-degree phase difference. There may be some angle changes. Then we can say that voltages are unbalanced voltages. But power factor measurement is applicable only for balanced case. But power measurement is applicable for any case. Understood or not? Okay. Balanced power means it is having only one power factor. That's why measurement of power factor is very easy. But unbalanced means it is based on the phase impedance. The power factor angle will be changes. That's why you cannot measure the power factor by using 2 wattmeter method. Understood? Okay, these points you remember with respect to 2 wattmeter method of power measurement. Okay, in the next session we will continue with what is the effect of power factor on wattmeter reading? What is the effect of power factor on wattmeter reading? Then how to measure the 3-phase reactive power using single wattmeter. That is a special connection. These 2 concepts I want to discuss. With that, the power measurement using wattmeters will be complete. Then we will start some classroom workbook questions. Clear? Understand? Okay, that you concentrate. Okay. One more time I am telling here, power measurement is independent of either balanced or unbalanced. Whatever may be, the wattmeter readings we can measure. The wattmeter measures the power. Okay. But power factor measurement is possible only under balanced case using 2 wattmeter method. Understood? Okay. That's why 2 wattmeter method of power measurement independent of balanced or unbalanced. We know that if any 3-phase system is under balanced condition, we can get the sequence currents. That's why a 2 wattmeter method of power measurement is independent of sequence components. Understood? Under unbalanced condition, we can get the negative sequence currents. In general, any system is having positive sequence, either balanced or unbalanced. But when you can get the negative sequence, under unbalanced condition, we can get negative sequence. If the system is under grounded, then we can get the 0 sequence also. But 2 wattmeter method of power measurement, particularly I am telling that power measurement, independent of sequence currents. Understood? Okay, that you concentrate. Thank you. In the next session, we will continue.